My name is Lendiuk, and I would like to present you the paper Evaluation the Efficiency of Information Technology of Big Data Intelligence Analysis and Processing by Myroslav Komar, Oleg Savenko, Anatoliy Sachenko, Lendiuk, Khrystyna Lipianina-Honcharenko, Grygoriy Hladiy, and Nadiia Vasylkiv. Today, big data has become a defining and growing feature of modern world economy, a vector of global change in almost all its sectors. But complex and structured data are difficult to access using traditional analytical methods. This is where deep neural networks come to the rescue, which have high reliability of nonlinear data conversion and presentation compared to traditional neural networks and allow processing and analyzing large amounts of data in various fields. The imperfection and limitation of existing approaches and methods don't allow to ensure sufficient efficiency of analyzing and processing of big data. Therefore, the development of methods for assessing the effectiveness of mining and processing of big data. The methodology of intelligent analysis and processing of big data, in the absence, incompleteness, vagueness, and uncertainty, is based on the use of the following principles, which are the basis of the developed models and methods. Some of them are basic principles of working with big data, which can be formulated on the basis of definition of big data. Principles that increase the efficiency and reliability of analysis and processing of big data. Principles that increase the efficiency and reliability of analysis and of big data processing. The basic principle of big data processing is mainly considered to be horizontal scalability, which provides data processing distributed over hundreds and thousands of computing nodes with performance degrading. The principle of fault tolerance is derived from the principle of horizontal scalability. As there may be many computing nodes in the cluster and their number, it is possible to increase the probability of machine failure increases. The principles of data locality. The principle of data locality, because data is distributed across a large number of computing nodes, it is physically located on one server and processed on another, the cost of data transfer may be high. The principle of ensuring resistance to data errors. When using informational technology to obtain reliable and high quality results, it is important not only the methods, ways, and means of obtaining them, but also the initial data quality. The principle of resilience to data errors based on data quality assessment involves recovering missing data. The principle of providing the ability to evolve and adapt provides the ability to develop the system over time in order to acquire better properties. And the principles of ensuring sufficient speed and data security involves the possibility of efficient hardware implementation and real-time decision making based on fuzzy logic. The proposed principles are the basis of the development of models and methods of data mining and data processing. Big data quality models that take into account 7 quality parameters which allow to determine the characteristics of these parameters due to the lack of correlation between them. Big data models for missing data recovery, which is based on the hierarchy of objects that allows processing structured and semi-structured data from source with different data structures. The method of classification of neural packets based on deep neural networks, which is characterized by reducing the dimensionality of the analyzed information in the middle of the network. A method of recognizing objects in the image of satellite images based on deep convolutional neural network, which allows to increase the reliability of images classification with poor quality and low resolution. A method of recognizing objects in images of test documents based on image preprocessing, which simplifies the localization of individual parts and subsequent recognition of localized block using a deep convolutional neural network. A method of creation and operation deep neural networks based on the evolutionary approach, which allows in parallel with the algorithm to find the optimal neural network parameters to analyze big data. Method of increasing the speed of analysis and processing of big data, which is based on preprocessing options for possible outputs of the deep neural network. For information support of the offered models, the methods and the information technology of intelligence analysis and processing of big data in the condition of their absence, incompleteness, vagueness, and uncertainty is developed. The input data proposed information technology of intelligent analysis and big data processing are parameters of neural networks, satellite images with the image of solar panels, images of text documents. The source information of information technology of intelligent analysis and big data processing are the results of the classification of neural packets, the result of the recognition of solar panels, and the result of recognition of text documents. Under certain conditions, a method of increasing the speed of analyzing and processing of big data can be used, which involves an operation to reducing the hardware complexity of the neural networks. The developed information technology of intelligent analysis and big data processing is presented in the form of structural model. Let's evaluate the effectiveness of the developed information technology for intelligent analysis and big data processing. That T0 be the time spent on data recovery, and T0 power j be the time spent on data recovery for each iteration of the j's process task. Then let the data recovery be performed to process the next Q+1 big data. The time for processing is denoted by T0 power Q+1 and defined as following equation. It's here. The value of T0OC power Q1 will be evaluated and normalized to take into account in the following stages of calculation the effectiveness of the developed methods. The next value is obtained as the average of all previous processing data for data recovery divided by maximum among the previous values. Therefore, this value will be less or equal 1. In the future, next value of time can be estimated from the previous values. And we receive such equations. Let's introduce an interactive formula to optimize following calculations. Then we will have the following expressions. The efficiency of system as a whole is defined as a value that takes into account the time for data recovery, time for data processing, and time spent on reprocessing. The minimization function of F minimum of the efficiency factor will reflect the best efficiency. In particular, we will present it as following. If P is equal 0, then we will receive KE coefficient, where KE also must be less or equal 1. If P is greater than 0, then KE may be greater than 1, which will indicate problems with the quality of the initial data, their recovery, as well as the effectiveness of processing method used. As a result of experimental study, obtained KE is equal 0.82. Therefore, the proposed assessment of the effectiveness of information technology allows to take into account the time to recover missing data, time to analyze and process data, and if necessary, the time spent of the reanalysis and processing. The methodology of intelligent analysis and processing of big data in the conditions of their absence, incompleteness, vagueness, and uncertainty is based on the use of following principles, which are the basis of development models and methods. Basic principles of working with big data, which can be formulated on the basis of definition of big data, principles that increase the efficiency and reliability of analysis and processing of big data. A structural model of information technology analysis and processing of big data has been developed. The results of experimental studies confirm that the proposed approach allows to ensure sufficient efficiency. In particular, it was found that the level of efficiency of applied methods of analysis and processing of big data was obtained, and the level of KE, which was equal 0.82. Thank you for your attention.